recording. All right, now we're live.
Nice.
So let me go ahead and copy this from here. All right, so hi guys. I'm David Beard, or Lost in My Frontal Lobe on Reddit, and I'm here with Brax. He is a junior software developer, which is awesome. And we're going to be practicing some joints today and any other thing that might pop up. Uh, I also feel like a noob, even though I've been obsessing on SQL for the last 2 months, and I guess it's part of imposter syndrome, where you basically think that hey, you don't know much, but you actually do. Let me bring up the game. You don't know much, but you actually do, and it's one of the things that you need to overcome. I'm pretty sure, Rax, have you have any experience with imposter syndrome when you're working in your current job or in your current role?
Oh, absolutely. We've got a DBA that knows more than I could even possibly begin to imagine, and working in and around that guy is just it's insightful and challenging at the same time because of those reasons.
I'm pretty sure it is. And how did you overcome it? Or is this something that you still feel once you're working, right?
It took about about 4 to 5 months, something like that, for me to really like just kind of he's definitely going to be better than me. He's got more experience, but eventually, if I work hard enough, I know that I'll be at that same level or better. So it just takes time.
Okay, awesome. Thank you for that feedback. So, do you know about joins?
A little bit, man.
Okay. So, I also know a little bit about it. Um, I don't use the sandbox SQL that much. I have MySQL. I also have Postgre. I managed to do a scraper, web scraper using Selenium, where I was scraping a whole bunch of data from different real estate websites here in Puerto Rico, and I was structuring the data in Postgre. And maybe later on, once I go to my other computer, I can show you guys my that project because I find it cool. It basically aggregates the data from different websites, and then creates one big table, which I display to a different website.
Yeah, dude, that
Well,
sounds dope.
yeah, that I kind of cheated because I didn't know how to. I don't know web programming, so I ended up using ChatGPT for that section.
I mean, hey,
But
it gets you pretty far. It's just the moment you go to like scale up, it gets a little tricky.
yes, it does definitely for sure. So if I don't know if you're familiar with the mathematics behind SQL, and SQL is based on relational algebra and relational calculus. And there's
No,
a Go ahead. I'm
I've
sorry.
never actually. I've no, like I seen the book that you mentioned. I've never seen it, never got to read it. So if you want to, like that's all new territory to me. So if you want to hit me, that's awesome.
No, yeah, definitely. Let's look over here. Algebra, UVMS. So let's look at an example here quickly. So it's relational algebra, and again, I'm not that too savvy of it, but it's basically a way in order to, like, if you're in high school taking algebra two, algebra one or algebra two class, you know that there was some notation that you have the word problems, and then you needed to transcribe those word problems into mathematical problems.
Yeah.
So relational algebra is basically the same thing. It's taking a word problem and transcribing it into a a a in this case it would be like a statement where you use different symbols. Let's look for an example here. Use different symbols, and each symbol is going to represent either a join, a select, etc. Here, here's a table. Well, there should be someone around here, but yeah, here.
Not hard.
So this gives you basically the union, no, the intersect operation between two tables, right? And we
Yeah.
can actually do the intersect because we have the commands in SQL for intersect, and we have the commands for union. Well, depending on the SQL product, since we're going to be using this product, I don't know if it which if it's it's based on SQLite, so I'm pretty sure it's similar to MySQL. So it should have the union and it should have the intersect commands.
Yeah. Yeah.
Anyways, it's very if you are good in algebra, once you start seeing this part of of SQL, it's going to be very intuitive in the sense that you're going to start to see the pattern and the logic behind all the queries. Because, for instance, the join operation is basically just a Cartesian product. So a Cartesian product is two tables, or in this case, it would be in the mathematical sense, is the joining the products of um, the products of two sets, as you can
Yeah.
see here. So we're doing the same thing in SQL. We're just saying, if imagine that you have one table here, table A, and one table B. So once we're doing the join, we're just basically doing this Cartesian product, just joining the two tables. However, one of the interesting things is that, as you know, in SQL, you can slice these tables. For instance, instead of if you want to select column A and match some value from column Z from the B table, then you can actually select for that in the select statement. And then if you want to filter for some specific condition, for instance, I want the table to just display the record that equals column A from table A and is record ID number two, then we can add the filter of where record ID is equals to two, or we can even use the subquery, which I don't think is necessary for this type of,
Oh,
a
yeah. Yeah.
simple
Yeah.
query. Yeah,
Yeah. Yeah. 100%.
definitely. But yeah, this it's the joins is a way to slice up those two tables. So you do the Cartesian product, which is the sum of all the records in table A and table B, and then you slice it with the different SQL commands and select. You're able to just slice the columns. The where is basically the data that you're looking for, or the data types that you're looking for. If you want to do some aggregates, you can group them. You can also group them based on different values. So now that we kind of got a good introduction, I think, hopefully it makes sense. I haven't recorded or done this type of, of education before, so this is my first time. I'm trying to roll with it, right?
Yeah. Yeah. You're good, man.
So
So,
here,
question:
yeah, go ahead.
Can we do something like can we like write just a simple join from I don't really know what's a good join. I need to look at these tables.
Yeah, let's see here. We have employee, we have customer. I mean, I think we can try to find all the customers that are also employees. That would be well, that would be a join.
Yeah,
Let's see.
that's a good one.
Also, there's product, there's order. I don't think I don't think there's an ERD for this one. So an ERD stands for Entity Relationship Diagram. It would be better if we had an ERD, but this is the norm. Actually, now that I think about it, in ERD. Diagram. I think since this is a common database that's used for practice, there should be an ERD for this available.
Oh, okay.
Okay, yeah, here it is. So we can see no, this is not.
There's no no, no
No, there's
relationship
no
between employees.
relationships here. So let's look for another one. Maybe this one. Um, I think this is one too many. Probably. we're getting there.
Oh,
Anyhow, so we can just investigate. So let's make it interesting.
that's
Or
like half my job, so
let-
yeah, totally.
yeah, you can also look on your end. Or if you want to ever present your screen, you can. By the way,
Yeah.
let's do this. So we have this table. Select employee, last name, first name. Select from customer. Okay. So the IDs are different, so we can't use that as a join. But for this just to make it simple, I know for a fact that we're gonna get a relationship between order and product. So let's do that for now. So
All right,
let
sounds good.
so for instance here we have customer ID. So we can do actually select start from customer C, uh, because we're in a join order O on C dot ID equals O dot customer ID. So this is an inner join. So it provides the product of all the matching records. So what I mean is, if you remember the example, well, wait,
Yeah, that's what I was running into too. It's like being weird. Is it a capital O?
I could, let's see here. Or, you know what it might be? It might be that order is a specific command for this website. Yep, that's the issue. So
Crazy.
you need to quote order sense. I think order is a specific, a reserved word.
Oh, like a keyword or something?
Yep, it's a reserved word probably for SQLite, and we can confirm it. SQLite reserved words.
Oh, that's silly
Yep.
then.
Yep, it is a reserved word. So whenever you guys, this is actually very good because we managed. Am I recording by the way? Yeah, I am. This is actually very good because I'm pretty sure you've encountered this issue where you're trying to select a column and you see like, hey, why is it not working? Then you just need to do a workaround and see what their error is. The error um, that we were getting, it's basically SQL error near or the syntax error. Since it was a syntax error, and I know how to read the syntax and understand the syntax as best as possible, so I kind of knew that there was an issue with this with the order for word, and I assumed it was a reserved word. That's the reason why I decided to just put these quotes on it and interpret it as a string instead of a command, for instance. But this is something that you do with a lot of practice, and you're able to identify those syntax those problems with a lot of practice. Um, what's your take
Definitely
on
takes
it,
time.
Rex?
Nah, it's definitely something that takes time, for sure. Takes time to just understand what you're seeing, just to even begin with.
Definitely.
Um, One thing I would say with keywords and stuff, I don't know if it's exactly like this with SQLite and even SQL, or just regular SQL, but I know in SQL Server that we do have the ability to like enclose your anything that could be a keyword inside like a set of brackets. So like whenever you're selecting so like in your select statement, say you have something like name, which could totally be a keyword, or like order, for instance, here in SQL Server Lite, you could surround it in little square brackets, and it'll negate it basically. It's a way to get around it.
I mean, we can try it here. You mean these brackets?
I don't know if it's gonna work in the from or
Uh,
in the join, but we'll see.
apparently, it does.
Does it?
Yeah.
No way.
Yeah.
That's cool. Right on.
we can also do, but I think you need to be careful because, for instance, this would be considered a list, or we can use it. Actually, no. Here, actually, yeah, it's considered a list. So there are different ones that have different meanings. So we need to be careful which ones we use. But the square brackets does work, and the quotes works as well. Um, but hey, here we have the products of both tables. And I know we can't visualize it because there's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 columns here. And in the order, that's in the order table. And the customers, we have 10 columns. So we're not going to be able to appreciate that we actually did a join because it's going to bring all the records and all the columns because we're just using this asterisk wildcard. I'm not going to get into much detail into what a wildcard is, but basically it selects everything from the table. And in this case, since we are using two tables, we're selecting everything from two tables. And I don't have enough.
So
Go ahead. I'm sorry.
so basically, we're selecting all the columns from both tables, right?
Yeah, yes, we are
Gotcha,
selecting
gotcha.
all the columns from both tables. Yes.
So we should, if you scroll across here, we should be able to see columns from customer and order.
Yes, we can. Look, here we go.
Got you. Okay, cool. It's just a nightmare to see because there's so many columns.
It is.
So maybe we
It
should select it down. What do we want?
awesome. So actually, let me talk about this for a second because the one of the books that I recommended, which is called Beginning SQL Queries by Carrie Churchill, something like that. I forgot her name. Uh, it explains that in order to break down that if you have an issue or if you have a business requirement or yeah, a business requirement or you have a query that you need to build.
Mhm.
Specifically, when it comes to joins, it's better to first do the biggest join that you can. In this case, it would be either full outer join if you're using my SSMS, which is SQL Server Management Studio, or you can just inner join. There's a way to do a full outer join here in SQLite and MySQL, but it requires you to do a right, a left join, and a union between a right and left join. It's just a little bit complicated. I don't know why MySQL decided to do that, but that's how they
Yeah, I
do
was
it.
gonna say that sounds kind of gnarly.
It is, it is, it is. But it explained the book explained that hey, let's first do a product of to see what we're looking at, and then look at the columns. Then, for instance, if you say, hey, I just want to see the names of the customers, since I haven't talked about alias, so I'm gonna assume that people don't know what alias is, even though I'm pretty sure you do. But since I'm recording, I'm
Yeah,
also
definitely.
talking out of third person perspective.
Uh,
An alias is basically like a word that you put in order to reference a table, and this is something that's used a lot in relational calculus as well. Once people start, maybe I'm gonna do a deep dive on relational algebra and relational calculus because I think it's amazing, and it's basically what helped me truly understand how SQL works. SQL works. So maybe there's someone that's mathematically inclined that's able to also put everything together based on relational algebra and relational calculus. By the way, side note, relational calculus is way easier to understand than relational algebra
oh, that's good.
because it's basically relational algebra tells you how to do things, and relational calculus tells you what you're looking for. Basically, what would be the how to you use relational calculus when you're seeing the table and you say, hey, then I want to grab the for instance the column. Let's do from customers. Let's do company name. No, let's do contact name. Contact name. C dot contact name. Let's do I don't know phone. C dot phone. And for orders, I want to select um, just to show the relationship. Let me do c.id.
Yeah, maybe. Do
Let's
they have a
do,
description in order?
I'm sorry?
Does it have a description in order? Oh no, it would probably link out to product, wouldn't it?
Yeah, probably.
Yeah.
But we can do a join between three tables after we finish this one.
Yeah. Sorry, sorry.
No, no, you're good. You're good. But now let's do customer ID. Oh, that customer ID, and just I don't have any. We don't have any specific requirement that we need to meet here, so we're just going to be selecting this. But just imagine that your boss asks you, hey, I want to get the name and phone numbers of every customer that has placed an order in our company, in our pseudo company name, Northwind LLC. And this would
Yeah,
be a
it's all.
good query in order to get that information.
Oh, are you using a shortcut to run this?
Oh,
To
yes,
like run
I'm
the
sorry. Yes, I'm using Control Enter.
Oh, control
I
enter?
just,
Okay, cool.
yeah, you highlight it and you do Control Enter. Um, I really don't. Oh, or you can just click on execute.
Gotcha.
I'm
Question.
sorry. Yeah, I'm sorry. Go ahead.
No, you're good. Um, so I guess what would you do if okay, so like explain the importance of aliasing like here. Like
Yeah.
why would you alias customer and order there?
So here we do have different names for it, but because this database is actually well built, and it's rarely you're gonna see this out in the wild. And I think Brax, you can confirm what I'm
Yep.
saying. It's not gonna be as beautiful as we're looking for here.
It never is.
So one of the reasons that we use aliases is because sometimes we do have common columns that have the same names in two tables. So in order
Oh,
to identify each column from a specific table, that's the reason why we use aliases. For instance, for if you see, we have ID in customer, and we also have ID in orders, and we're looking we're actually I can show this. Let me let me do ID. Select ID, no aliases, right? So it's gonna throw an issue, an error, and it's gonna
it's
say, hey,
ambiguous.
it's ambiguous. Yeah. And that's the reason why this is the main reason why we alias once we're doing inner joins, because we need to identify, hey, which columns I want to represent from which tables. And we know that sometimes we have, um, we might have similar column names. For instance, here, in order to overcome this, you can add another alias, which is as customer ID. And I think customer ID would throw an issue as well. So I'm just going to do add to close customer ID, and then we can select o.id as order ID. So this would solve that issue
Yeah.
because we're basically just aliasing we're aliasing the tables. We're using the table alias that we produce in the from statement, and we're aliasing the columns themselves in order to describe what we're pulling. Because if you don't do this alias, if you see on the top of it, you see order ID and you see customer ID, right?
Hmm.
And since we have customer and order ID, we can we're able to differentiate. But let's go ahead and assume that you don't know much about this data set, and we don't know what those numbers mean, and we end up um, doing this executing this query. If you notice, we're just getting the ID information,
Yeah.
right? And this is because first, well, I'm not entirely sure. I think. The reason why we're not getting any matching information is because it's just aggregating both into one
Yeah,
column,
pretty sure that's
right?
what's happening. That's weird. Yeah.
So it's if we were to do this in SSMS or MySQL or in any other databases, we will actually get two columns. So I think this is a SQL like specific thing
Has to
about it.
be.
But yeah, that's the reason why we alias both the
So,
tables and the columns. Hopefully, I did
so
explain myself as best as possible.
no, that was solid. So can you do it without aliasing it, or is it impossible?
um, I mean, we can
Say I
definitely
didn't.
try,
Say I
but I
didn't
think
like.
I like you mean the tables if we don't alias the tables.
Hmm.
So we can, but we're gonna still run into the same issue once we're selecting the columns. If we do a wildcard here and we select everything, right?
Oh, it's gonna
Uh,
make you get the
oh,
alias on the join.
yep. But even that, if we do that, it's still gonna throw. It's still gonna have the same issue because on the on statement in the inner join, once we're doing the inner join on the on, if we don't properly alias, we don't have a way in order to identify the relationship in the tables. So that's the reason
So
why we need to alias the tables as well.
can you just write out the whole customer name or customer table and then say dot ID? Is that a
Oh
thing in SQLite?
yes, no, yes, you can also do that actually. Instead of aliasing, you can do customer.id and order.customer ID, and this actually works.
Order? Oh, the
Yeah, we
okay.
were having the same issue we were having before. There we go. So that
Hey, we
actually
got it.
works. Yep.
And then so then when you go to select columns from each of those tables, can we can we just say customer.id and then
Yep.
order.id?
Yes, we can. We can also do that. So we can do customer. Let me do this one that I have saved up. Hi, Abby.
Hello.
We are recording this session, so I'm gonna be uploading it in a YouTube channel that I have, so you guys can reference it later on. Uh,
Okay, thank you.
but yeah, we're just going over the inner join right now, or the different joins. Previously,
Okay,
we did discuss some different topics. Basically, what is a join and how it relates into mathematics term. What is a Cartesian product and relational calculus, relational algebra, etc. We did cover some, just basically what it is and how it relates to SQL. But yeah, welcome,
okay, perfect.
welcome.
Thank you.
And I think we have Manish as well. Hi, Manish. I think he's muted or anything like that. Regardless, let's continue here. Um, so where did we leave off, Rex?
Uh, Instead of aliasing
Oh,
our tables, we were just using the table names, I think.
yes, yes.
Yeah,
We
yeah.
can use the table names instead of aliasing them, as you beautifully stated. For instance, we're doing customer, order.
And you could totally see why you wouldn't want to do this.
Yes, yes. That this is a beautiful example of why we wouldn't just use the table name. But you're correct that we can use the table name itself instead of an alias. But if you notice, you needed to type with almost 30% more, well, actually
Easily.
40% more, 40% more, like actually writing down the full with the full names of the tables instead of just aliasing them. So you can see when we can do an example here. Let's compare it. Select, see that contact. Actually, I have a couple of this from customer C inner join um, row row on custom C dot ID equals whole dot, I think it was customer ID. So we can compare both of them. Both of those of these queries do exactly the same. It brings it pulls the customer name, the customer phone number, the customer ID, the order from the customer ID matching the value, or doing basically the relationship, the order date from the table. They do exactly the same thing, but if you notice, one it's much more compact than the other. And this helps in two things. It does help in, let's go ahead and say that you are working on tables that have millions and millions of records. And you can ask, hey, how is this just one word, an alias, how is this impacting performance? And it does, because it, it impacts the reporting just a little bit, and not as much as, for instance, if you're not properly indexing. And this is something that we're going to be discussing later on, what's indexing, how to make better queries. For instance, if we're doing a bunch of joins and inner joins, maybe we can use, as we previously spoke, CTEs in order to improve the performance, right? But we need to be careful how we construct the queries if we're working on a big database, because if you're using a product like Snowflake, for instance, and Snowflake, every time you execute a query on Snowflake, Snowflake charges the company, or in this case, let's go ahead and say that you are the business owner, right? And charging you for the runtime of the queries. So if we have this query that's running, what, 30 seconds, assuming, let's assume it's going to run 30 seconds, and you're able to optimize it to run 15 or 10 seconds, you're going to be saving money just by knowing how to properly format the query to run better, if that makes sense.
Mm.
And the same thing happens with BigQuery, Google BigQuery. They also charge um, per query time runtime. And I think Amazon is the same thing. And by the way, BigQuery, Redshift, and not Redshift, but yeah, Redshift, BigQuery, and Snowflake are all what's called OL8P system, which is analytical. If you guys know anything about data warehousing, those are terms that's going to be familiar with you. But Brax can actually explain this better than me. There are two, because I'm pretty sure he works with it on a daily basis. There are two types of databases on on the on the data pipeline. The first database type is called a transactional database, which is OLTP, which is used in order to information, store information and access it for application purposes. And there's OLAP, which is used for analytical purposes, which is what I'm doing, because I'm more interested in the data and the analysis portion of it. And I know Rex is working as a junior dev, so he can actually explain how he's work. I mean, if you're up to it, Rex, right? Can you explain
Actually,
how?
actually, no. You know more on that than I do. I currently where I'm at right now, we have a production database that just a simple MySQL server, and then we replicate over to another database to get reports and stuff run. So you know more, way more on that than I do.
No, no, that's actually beautiful, because you explained the whole process. That's basically what it is. That's a data pipeline. Well, we need to add the reporting portion of using either Power BI, Tableau, whatever reporting tools you're going to be using in order to build the dashboards. But that's basically how it works. You have the database at first, gets all the information from each transaction. That's what is called a transactional database. For instance, a new customer record, a new order, etc. goes from the application into that database, which is the main database that you mentioned. Then, if you can do the reports from that database, but it's going to impact performance, and which might impact the application performance, which might impact the customer experience. We don't want that. That's the reason why we have that separate database, which is the analytical database, where we query directly from that database, not to impact the performance of the first database. So that's the whole logic behind the OLTP and the OLP.
Huh. That's totally new to me. Right on. Well, I mean, I guess I knew it, but I didn't know it.
It seems that you worked on it, but you didn't know the specific terms. That's what it
Yeah.
sounds like.
100%. The one thing is like I'll say that goes even a layer deeper. So where I'm at right now, we have an internal system that uses this one main table for all our invoices, right? And then we have our website that uses the same database, but what we do is every night we replicate tables. I'm not saying this is good practice, but what we do is every night is we replicate certain tables so we don't have to like hit the database that the internal system is using to like so we don't slow it down from the data or from the website side,
I mean,
which I don't know.
you can do scripts in order to do that. You can automate the scripts. Like one of the scripts that I did in the previous, because I work as a consultant and in Puerto Rico, it's it's a a consultant for a government agency, and what they were doing, they were manually entering the information. So what I ended up doing is, in order to transfer the information from one database to another, I I built a Python script, and on that Python script, I just put out the logic in order to do the transfer, and then I used I think task scheduler on the server, and with a bat file, I programmed the bat file in order to um, execute on the once. Okay, so the test scheduler calls the bat file, and it's done every day. I think it was done every day. So you can do a similar solution, so you don't have to manually do it. If you have access to the server itself, you can just build a Python script in order to run the script itself. And if you remind me in the week, and I can access my other computer because right now I'm at my girlfriend's house. But if you remind me within the week, I can show you some examples of how I did it, and I can share with you those files, so you can just do the same thing, run the map file and do it automatically. That way you don't have to do it manually.
Yeah, that'd be awesome. I just recently learned that task manager or not task manager but task
That's
scheduler was
scheduler.
a thing. It's crazy how much like how many business processes run off that.
No, yes, everything. You see everything, and that's basically how automation sort of works on servers. But yeah, I think we got sidetracked there.
Yeah, a
Let's
little bit.
continue with the inner join here. And all right, inner join. So this basically has the Cartesian product, or in this case, the result set of both the customer and the order table that matches on the ID equals customer ID column. So let's go ahead and say that there's for the customer record, there's an ID here that doesn't match the customer ID here. So since we're doing inner join, both of those, the record is not going to show up. However, if instead of inner join, we do a right join. If we do a right, actually, I'm sorry, let's start with left join. We do a left join, and the order matters here, by the way. The left table is customer, and the right table is order, right? Because it's the first one that's on the from clause. If from the from clause, if we have the first table would be the left table, and the second table will always be the right table, and it's always going to follow that order. But let's go ahead and assume that, hey, we do, instead of inner join, we do uh, a left join. Then if we have a record here that doesn't match a value on the right table, we will see that record, and we will just see nulls for the columns, for the orders column. The same thing applies if we do a a a, a right join. If we don't have matching value for from the order table in the customer table, then we will get the information from the order table. However, we will just get nulls in the customer table. So that's the reason why inner join is gonna be 90% of what you're gonna be using. And in specific use cases, you will be able to use, for instance, if you have a table, let's talk about business use case. If you have a table in which you just want to display all the information from one table and you don't mind that it doesn't match all the values from the other table, then you can do that with the right or left joins. But I think in most instances, you're either going to be using inner join, or if you're using SSMS, you're going to be using um, full outer join. And well, there's inner join as well, but full outer join. Actually, let me correct myself. Sorry. There's a difference between inner join and full outer join. Full outer join provides all the values from all the tables. It doesn't matter if it matches or not. It's going to match the tables, right? But for instance, if we have a record missing here or a record missing in the customer table, we have a record missing in the order table, you're still going to get those records. They're just going to have no values. Inner join just provides the matching records. Full outer join will provide all the records, all of them. And yeah, I think that's a good introduction to joins. I did more theory than practice, and I did show the practice here, right? I never used where, so for instance, I never use any type of filtering. Like if we can quickly practice that, let's go ahead and say that for city, let's add city here, see that city. Hey, wait,
Oh, that's the query with the not
uh,
alias tables.
okay, let me delete this way. And let's do, and thank you for caching that.
No, no problem.
See that city. Now, let's execute this. And let's go ahead and say that we want to filter, actually, let's do an aggregate function. Let's do group by, um, let's do o.id, and let's do count. Let's group by, let's group by, actually, do that. The grouping, o.id. Yep, works. And we can order my all that ID. Whatever. I think just everyone just made one order.
Yeah, it looks like it.
Yeah, but basically we can also group by cities. But yeah, well, it's expected from this type of database. Remember, this is a practice database, so if in the real world, in the real database, we would see different results. Like for instance, um, let me change that column name. Oh, it looks better. But yeah, basically, this is basically how engineering works, and you can keep adding clauses. You can keep selecting different column names, and you can keep modifying as is. But the structure, let me go ahead and repeat the structure here, and I'll show you here. So the first step, whenever you're dealing with any joins, is first do the biggest join possible, and then you start filtering each join subsequently. You start refining the query as you want. Like we started first with the wildcard, the asterisk, the select asterisk um, from table one, inner join table two on column ID equals column ID, and then we kept we see that we saw the whole product, or in this case it's called the Cartesian product of both tables, and then we started examining it visually, looking at the data, and then we cross-referenced the the requirement that we were given by our boss, and hypothetical boss, of course, and then we started refining the table until we finished with this table, which gives us basically how many orders uh, each customer has done. So that's has been the practice for inner join, and I think that's all the fuel I have for now. I thought I was just going to be here 30 minutes, but it ended up extended by 30 more minutes because I did find it enjoy it, and I also enjoyed my conversation with Brax as well. He gave us a lot of insight on his current workplace and how things work and how he's doing things on his end. I did give some experience on what I have done in the past, but once I finally pass the interview for this new job, I will have more examples. The final interview, I will have more examples on what I can share with you guys. Assuming that I'm not broaching any information or any proprietary information, of course, I'm going to use analogous information so I can keep helping you guys. By helping you guys, I'm also helping myself because I'm practicing and integrating more and remembering things that I didn't remember. So I do appreciate you guys joining and accompanying me in this endeavor.
Yeah,
Thank
man.
you. Thank you so much.
Definitely. And Abby, I'm sorry. I know you got in the middle of it,
No,
but
it's okay. Don't
I,
worry. I actually understood a lot of the things you were saying, and sometimes when I try to practice, I get a little bit confused which join I should use. Like, should I use left join, right join? But I really liked your explanation of, the order matters. So the first one is always left, the second table is always right. But then what about if you have like three tables? But that's a whole different thing, right?
no, it's the same thing. Exactly the same thing.
So
So
how do you order that if there's three tables?
if you have three tables, then what you can do is you can add brackets to them. Like you can add a bracket here. Uh, you can add a bracket here, and then do inner join. Um,
Oh, you
what's
make
it called?
you make
Yes.
two different joins. Ah, okay,
Yes,
okay. I got
exactly,
it. I got it.
exactly. So
Okay.
the beauty of this is that it works just and this is why I mentioned relational algebra and relational calculus, because it works the same way as if you were doing an equation. If you add brackets, there's going to be a
Okay.
certain order of operation, and SQL is going to follow the same order of operation because SQL is based on relational algebra. On the back end, it's all algebra basically.
Okay. Okay. I got it. Thank you.
Awesome, yeah. But and to answer your second question in regards to the use case for the left or right joins, it all depends on what requirement you have or work requirement you have, right? Or what your goal, your end goal is. So that's in order to identify if you're going to be using right, left, inner join, outer join, whatever, you need to look at the requirement first, or was
Mhm.
required from you, or what did your boss or did the stakeholder or the SME, which is the subject matter expert, ask you to gather from the database. And once you analyze that statement, you're going to be able to identify if you're going to be either using an inner join, left, right join, outer join, union, etc. Well, it's very rare you're going to be using a union or intersect, to be honest. The only way you're going to be using union or intersect is if you're doing an OBC or one big table, which is used for analytical purposes. For instance, if in the previous example, when I was talking about the transactional system and the analytical system, um, there's a thing called data normalization. And data
Mhm.
normalization is basically just putting things, when you normalize tables, which is something that perhaps I think does in his day to day since he's a developer, you're normalizing, you're basically making sure that you don't create big tables. Like, for instance, let's go ahead and you have a customer and you have an order and you just decide, or order and product, and you say, hey, since I'm programming, I'm going to add the order and products in the same table because it makes sense to me because we're going to have access, we're going to access all the information in that table. Normalization, and there's different normalization tier. There's one normal and one normalization, two, three, four. Normalization means basically reducing the table sizes and joining them based on the relationship in a way that makes sense. Now, for analytical purposes, sometimes you want to denormalize the data for performance purposes. So you can actually join tables and use intersect or use unions or intersects in order to join those tables and create those tables and then just query those tables directly for performance purposes. And why is this important? Because instead of you telling the SQL engine, hey, I want you to reference this table and look at this other table from this other database or this other section of the database, you're just saying, hey, you're pointing to just one table instead of asking it to
Oh,
look for different
okay.
tables. So it helps performance. And that's the reason why you would
Right.
be,
And also the oh, sorry.
oh no, go ahead.
And
I'm sorry.
also, does it also affect the runtime, right? Like how you mentioned how companies charge for runtime of the query,
Yes,
so normalization helps with that as well.
yes, for sure.
Okay, okay.
That's one of the main reasons why we do have the OLTP and the OLAP systems. Because if you think about it, OLTP and OLAP are the same thing. They can be based on the same on the either on the same database, DBMS. They're going to be based on the same database. They can be based on the same database. But what makes it an OLTP or an OLAP is how it was designed. So if one was designed in order to get transaction information from application, that's usually a transactional system, which is an OLTP. But if another one was designed in order to get for analytical purposes and for reports and so forth, that would be an OLAP. But it's the same thing basically. Some companies do have
Okay.
different products. Like for instance, Google has they have their own section for data lake, and they also have the BigQuery, which is for the transact for the analytical system. And the reason why they do that difference is because they do charge different rates. For instance, for transaction, they're not going to charge you the same rate as they do for analytical purposes. Because for a transaction, they know that you're going to be doing a lot of transactions. For instance, a website like Facebook, they do have it on the service, but let's go ahead and assume that Facebook decided to get the Google services. And every time you do a comment or you write a message, that's a transaction. And that's going to be stored somewhere, right? Imagine if Google charges 10 cents per transaction for customers, or every time you send a message on Facebook, or every time you do a comment or you post something. That's a lot of money for the amount of user base, right? But for analytical purposes, it's a little bit different because they know that for analytical purposes, you're just gonna do a query once a day, once a week, depending on when you need to analyze the customer data or look at how the business is running.
Okay, I
But
got it. I got it. Thank you so much.
of
Thank
course,
you.
hopefully that explained it. I was able to explain it. But I think
Yes.
I'm done from my end. I'm not gonna edit the video. I'm just gonna upload it as is. Brax, do you have anything you want to share with us? You've been amazing so far, by the way.
Nah, man, you're good. I think that's a solid spot. That's a solid spot.
Awesome. So
The only
awesome.
thing I was gonna ask, if you're not too gassed out,
No,
is
sure, sure.
um, what what are we joining on, and why is that important?
Can you rephrase that question?
Yeah, so I see that we've got this inner join on, and then these IDs, so C dot ID and then O dot customer ID. Explain that, like explain how we're able to join on those things.
Oh yes, for sure. That's actually one of the main reasons why I decided to bring those two columns. And let's do this. Let's delete these. Let me delete these. Let me delete this. And this is gonna provide your answer. Uh, join. There we go. There's no sync though. Let me see. Oh yeah, I have an additional. No, it should work. Okay.
Yeah, at the select, I
Here,
think, yes.
here we go. This is where we're joining.
Okay, I
So
got you.
this is basically what builds a relationship. The ID, and I'm gonna alias this as ID ID from customer table, and as ID customer table ID in order table. This is where we're joining. If you notice, there's a matching value for this for each of those records. In an ideal scenario, these are this is a primary key and this is a foreign key. And there are certain restraints for primary and foreign key. For primary and foreign keys, you cannot have duplicate data. That means you cannot have two rows with the same value. So assuming that this follows and this that is it, and it is a primary key by the way because I see it here on the database. So we're not going to have duplicate values, and we can confirm that by the way. I'll show you how. This is where we're joining. So this is basically what's building relationship between the order and the customer table, which is the customer ID on the order table is referencing as a foreign key for the ID in the customer table. And that's where we're joining on. And that's where we're doing the relationship in. Does it make sense?
Yeah, I think I'm on it. So the ID is always going to be unique, right?
In, in an ideal
In a perfect.
scenario or in a well-designed database, yes. Why do I say this? Because there will be times where we will access databases that will not have this restraint. And then you're going to need to figure out ways on how to create or emulate simulate the primary ID by using different columns and using regex and regular expressions in order to build to create basically a primary key in order to do the relationship. And that's in a poorly designed database.
Yeah, thank God I've never had to run into that.
No, no, it is. I've seen things. I've seen things,
I
and
believe
they're
for
not,
sure.
they're not pretty to work on, to be honest. But hey,
Yeah.
once you have a job, you need to work on them, and you need to roll with the punches.
and that's a heavy one for sure.
Yeah. No, but
So
it's not that
basically,
bad. I'm sorry. Go ahead, Rex.
it should be unique at the very least, and
Yes.
it should be like by all accounts. And so then anytime there's a order put in, then we put in a customer ID that associates with a unique customer, right?
Mm-hmm.
And so
Yes.
therefore we're able to join based on that
Yes.
primary
So
ID.
so if let's think about it. Let's use programming. In this case, that's no that's fine, Abby. I'm gonna be. I'll try to log in tomorrow at the same time. But again,
Okay, thank you so much. Thank
I'm
you.
gonna be recording other sessions, so they're gonna be available, and I'll put the link once I
All
upload
right,
it.
thank you.
I'm pretty sure it's gonna take some time because we've been an hour here. But don't worry.
Okay, thanks. Bye.
But in your case, bye. In your case, bye.
Bye bye.
See you, Abby.
Let's go ahead and say that you built a simple CRM, and every time you create a new or a customer registers or someone registers an agent registers a customer using the CRM, then
Yeah.
there's going to be a call from your application, possibly using an API or just yep using an API to the specific database product that you're going to be using, and that call is going to use all the fields that the agent inputted. That's on the program on the UI, and that call it's gonna I think it's gonna use JSON. Well, it depends on how what the process is, but it's gonna translate that into JSON, and then that JSON is gonna have matching columns for each of those input fields from the application in the
Hmm.
database. And it will only work if and only it meets a requirement. So there are going to be different checks. For instance, let's go ahead and this is why you can't have the two emails from the same product with the same name, because this is basically what what's doing on the back end. It's checking the database if that email exists. If that email exists, it's not going to let you create or use the name of that email. The same thing goes here for a customer. If you're registering a customer and your product, in this case, you did the logic or it automatically, actually, it's going to be automatic. You don't have to code the logic for this, because if you try to input a record that has a constraint on the database, then you will automatically get an error, and the API is going to post that error, and then you're going to need to debug and say, hey, what's going on, right? But
Yeah.
that's basically how it works and how this constraint works and how it's implemented and how it's enforced. I hope that made sense.
Yeah, that makes sense. Yeah, we're good.
Awesome. All right. Anything that you want to add?
Nothing, man. Did a great job.
Awesome. Thank you, and thank you for joining. And if you guys are gonna log in, it's gonna be the same time, 9 p.m. Eastern Standard Time. And
All right.
thank you for accompanying me, being a spectator and also helping me with building the queries and your questions. Racks were fantastic because it did help me align myself once I was explaining it. So you were amazing. Hopefully,
Hey,
I can
man.
see you tomorrow as well.
No promises, but maybe, man. I'll see if I can make it happen.